top FTC teams like 4017 managed to pack incredible performance into really compact robots. And understanding how they do it can give your team a serious edge. They brought a clever bot full of different mechanisms and smart driver automations to the World Championships this year. Seeing their approach, especially their autonomous and driver assists, offers some valuable lessons. I'm Coach Pratt, with over 10 years of robotics experience and having coached national FTC champions and Inspire Award winners. I've seen firsthand what sets top teams apart. In this video, I'm taking you behind the scenes for a close look at Team 4017's robot. We'll break down their intake, their outtake, their lift, their autonomous pathing, and some of those slick automations that really simplify driving. You'll definitely find ideas here to bring back for your own design process. Here's a quick breakdown of the 2024 FTC Seasons game Into the Deep. The game is played on a 3x3 meter field with 2 alliances, with 2 robots on each red and blue alliance respectively. Robots had to go into the center structure to collect plastic rectangular prisms and place them in the respective baskets on the corners of the field for 8 points. Or they could bring a sample to a human. This human adds a special clip to the plastic piece, and then that allows the robot to hang this piece from the center bar for 10 points. In the last stages of the match, the end game, robots could hang from the bottom rung for 15 points, or grab the bottom bar, lift themselves up off the ground, and then grab the top bar and lift themselves up for 30 points. There are more complexities to the game, but that's a rough idea. Now, let's see how this robot managed those challenges.
What we do is we extend this submersible. We extend around 18 inches forward. We grab the sample. We have a differential, so we can twist the claw as well as raise it like that. And then if we're running specimens, we'll actually just keep this to the side and bring it back.
Yeah,
so what we'll do is we'll drive up to the human player. This will be a field wall. The specimen will be hanging, and then we'll grab it like so. This will flip over, and then the clip will be facing this way.
Okay, yep.
The lifts lift up, you drive into the bot, and then we also have this extension.
Oh, do you use the extension to drive it on, or do you...
So we extend first, and then we use the drivetrain to drive it on.
Yeah, because if we don't have the extension, it's too short.
Yeah, okay.
And also the extension by itself is not strong enough to fully push it.
Yeah. So use the momentum of the robot.
Do you use a laser for doing your polycarb here, or do you use...
these ones are CNC.
Okay,
but some of these are laser, like these plates made
are laser.
Yep. Do you use...
I think these are also laser.
What kind of material are you using for that? Is that polycarb?
No,
acetal?
Yeah, acetal,
Okay.
We have some polycarb here for anti-tip. So
really
far. Our robot tips. But also while we have blades, which double as a mounting point for our FRC inspired bumpers. Right?
Is this also a ballast?
Yes. We also have that here. So that
and that's just so your wheels.
It's so
you have
that
a flat.
It's like a sharp edge, and when we tip forwards, we get a lot of fuel damage. Our tires at home completely.
Yeah, and this is for to stop the lifts from hitting.
Oh yeah. That's a great little piece.
Yep. And we have our odometry pods here. Go build
the four-bod.
Yep. Do you use a pinpoint?
Yeah, we have a pinpoint right here. It's hidden in our bot right there. Core stages of lifts so we can reach the high basket easily, even go higher, honestly. This is the motor for the extension. Just simply belted. Only one side is actually strung here.
Okay, and you found that was sufficient enough?
Yeah, absolutely. It's very fast.
I really like what you've done here with having a laser cut or CNC'd section, and then a little 3D printer adapter to be able to hold your ball bearing on, your V-groove bearing. That's a great way of keeping your linear slides nice and close together, while still... Have you found that that's provided enough support for your strings? Yeah. Well, clearly, because even up on the top, you've got that too.
Yeah, and this supports all of them.
Cool.
And we have a level 2 hang. And these are just 2 sprung hooks. So like the hooks, like
so. There's a servo here, as you can see, probably or here. The servo.
Yep.
And that's a spool.
It's in continuous rotation
and when
mode.
that
spools up, it'll pull it in.
Yeah.
And then the hangs
so
just want to be like they're sprung outward. So
if I pull on this just a little bit, it goes like that.
100%. How does this rotate back?
It does
It
not.
doesn't.
We hang out the front. So
you release it.
Yeah.
If we fully extend our hang,
Okay.
we can just get onto the bar by driving it.
What extends it?
The servo.
The servo is
You see this
the
spool right?
string.
Do you have 2 strings on there?
Yeah, so one for this one and then one for this one.
And then
Okay.
this one's just
Notice if I pull on this also goes down.
Yeah,
right?
it pulls it down, yes.
And so we just wind this, and this will pull this, and then at a point, this also gets pulled downwards.
Okay. So that pulls you up.
Yeah.
That pulls
I guess my question is, what forces it out? Or do you start the match with it out? It's constant spring tension, so it always wants to be pushing itself out.
Yes.
Well, yeah.
Okay, there's an expansive string in here.
It wants to always go this way.
Oh, you can see this
Because
is the
you can
expansion
see
string.
the bungee cord here.
Ah, okay, yes.
For
Now I
this,
see what's pulling it out.
For
Okay.
this entire module, this is counter string this way.
Yeah.
too.
And then we
Now
have
I see
a
it.
zip tie here to limit the rotation.
Yes. You've also managed to keep this quite compact,
Very
too.
compact.
Yeah.
It's like
12 by
11
12
by
and a half.
Yeah, it's like 12 and 12 and a half.
Well,
and
the
it's like
bumpers.
16.
What the bumpers is 12, 12 and a half. If not, it's like...
It's like 11 and a half, 11 and a half,
Yep.
and then by like 16 to
Yep.
lifts. So if we start off in specimen mode, we can extend forward and
There's
it'll
one
go down.
button.
Yep.
And let's say I have one right here. So I can adjust the rotation with these bumpers.
That's
And then-
one button to grab.
That's one button.
Oh,
to
that's
grab.
nice. Yep.
And then you press the same button to extend, and
Yep.
it can retract as well.
Okay, so it's a bit of a toggle switch. You
Yeah.
press it, it comes out. You press it a second time, it brings it back.
Yeah. And then if I had another sample.
Yeah.
So let's say we have a specimen back here, and I press now if I press X,
Yep.
it'll drop that and go to the.
That's handy.
And then when we score it, it'll just release, and then it'll go.
Yep.
And now let's say that I wanted to switch to sample mode.
Yep,
We would just
yep.
press circle,
Uh-huh.
and then we could switch.
Mm-hmm.
And then it's like the same mechanics, except for once you extend out.
I see why you guys need the ballast and you need
it's
that little
very-
bumper on the front.
And then
Because it
if-
really does.
Now we have our.
And then we
Yeah.
have the transfer sequence.
Uh-huh.
Pull up.
Yeah.
And also we have a button to switch between high basket mode and low basket.
Yeah.
What are you guys most proud of about this season?
The FRC inspired bumpers.
That's cool.
No, but
I mean, you say it as a joke, but you know what? Legitimately having some swag on there is a big
Yes,
thing,
that
right?
looks
It's a big
great.
thing.